So everybody, today we'll start the cardiovascular system that includes, the heart, blood vessels. Cardio is heart, right? And vascular is blood vessels. So the heart and the blood vessels. What are the blood vessels? Arteries, veins, capillaries. Okay, those are three types of blood vessels. Together form the cardiovascular system, and you know that blood circulates inside the cardiovascular system, so blood is also a part of this system. So first we'll talk about the heart, a very important organ in your body, right? We'll talk about the location of the heart in your body. We'll talk about the blood circulation in the body. Then we'll talk about the coverings of the heart, surface of the heart, wall of the heart, cardiac muscle or heart muscle, and coronary circulation, and the valves of the heart. First, the location of the heart. Heart is a cone-shaped organ, conical organ. The shape is what? Conical or cone-shaped. The size of human heart is the size of your fist. So the human heart is this size of your fist. Location. Heart is located mostly in which side? Left side of your thorax, right? Mostly. That means a small part goes to the right side. 2/3 part of your heart is located in the left side of the thorax, and 1/3 part in the right side. Make sense? So mostly in the left side. Here you see, this is the midline, right? So most part is in the left side, but 1/3 part is in the right side of the thorax. Heart is located between 2nd and 5th intercostal spaces. Between 2nd and 5th intercostal spaces. That means if I see the intercostal spaces, you see this is rib 1, first rib, second rib. So this is first intercostal space between these two ribs. Then second is here, between 2nd and 3rd rib. So upper end of the heart is here, and then 3rd, 4th, 5th. So the lower end comes here. So that's the upper and lower boundary, 2nd and 5th intercostal spaces you see here. Then heart is located between two what? Lungs. You have two lungs, right? And heart is in between. So I can say that heart is a cone-shaped organ, right? The size is like the size of your fist, sitting in the thoracic cavity. 2/3 part is in the left side, 1/3 part is in the right side, right? Mostly in the left side, and in between two what? Lungs. Is it clear? Now, between your two lungs, this is your right lung, this is the left lung, and the space between two lungs is called mediastinum. So this space between two lungs is called mediastinum. and your heart is located in the mediastinum like this. Okay, so heart is located in the mediastinum. Now if I ask you, heart is located in upper part of mediastinum or lower part? Lower part, right? Makes sense? And then you have large blood vessels, aorta, pulmonary trunk, right? Vena cava, those blood vessels are mostly located in the upper part of the mediastinum. Make sense? So these are the blood vessels here, right? And this is the heart. So in the upper part of the mediastinum, you have the large blood vessels, and heart is mostly located in the lower part of the mediastinum. Okay, is it clear? Okay. So that is the location of the heart. Okay. And between upper end is in second intercostal space, and lower end goes to fifth, right? So that's the upper and lower boundaries. You need to know the location of the heart because, if you want to listen the sound of the heart, right? You need to know where the heart boundary. Surgery, cardiac surgeons, right? They need to draw a line before they open, right? So they need to know, they need to count the ribs, intercostal spaces, right? And they can locate better. So that's the location of the heart. Now, heart rests on the diaphragm. So this is the diaphragm, a flat muscle. So heart rests on the diaphragm, and the heart is attached to the diaphragm very strongly by fibrous tissue. So you have fibrous tissue here. That strongly connects the heart to the diaphragm. Diaphragm, have you heard that? Diaphragm here, located here, the flat muscle that separates the thoracic and abdominal cavity. You have learned in NP1 the cavities, right? And it helps in breathing. Anyway, so just know that heart rests on the diaphragm. So here you see between two lungs, this is the diaphragm, this is the fibrous tissue, okay, and this is the mediastinum, the space between two lungs. Heart is located in the lower mediastinum. Blood vessels are located in the upper part of the mediastinum. Okay. Now, circulation. In human body, we have two types of main circulation. First, if we divide the circulation, we divide this way: adult circulation and fetal circulation. Now, if you see in the adult body, human body, we have systemic circulation, pulmonary circulation, and there is another circulation that is called hepatic portal or portal circulation. Okay, so those are three types of circulations in the adult human body: systemic, pulmonary, and portal or hepatic portal circulation. Fetal circulation is in the fetus. You know, when the fetus is in the uterus, mother's uterus, right? Blood goes from mother's body to the fetus. So between mother and the fetus, right? So that is fetal circulation. Provides nutrition and oxygen to the fetus from the mother's body. So that is fetal circulation. Now let's see hepatic portal circulation. Hepatic means what? Liver, right? I think most of you know hepatic disease or hepatic, uh, hepatic, we say that failure, liver failure, right? Hepatic is liver. Hepatic portal circulation, that is the circulation between your intestine and the liver. Between the intestine and the liver. From the intestine, nutrients are taken to the liver. After you eat the food, right? Nutrients from the intestine, we all know that, right? Nutrients from the intestine are taken by the blood, and blood takes that nutrients to the liver. Make sense? So between the GI tract and the liver, that is hepatic portal circulation. So what kind of blood goes from the intestine to the liver? Nutrient-rich blood. Is it clear? So that is one type of adult, in adult body, one type of circulation. Now, the systemic and pulmonary, these two circulations are connected to the heart. Connected to what? The heart. Hepatic portal is connected to the intestine and liver, right? Not heart. But systemic and pulmonary are connected to the heart. Systemic circulation is the circulation between the heart and the body, whole body. Heart and what? Whole body. Okay. Pulmonary circulation, the word pulmonary means what? Lung, right? So between the heart and how many lungs you have? 2. Okay. So that is the pulmonary circulation. Make sense? So between the heart and the lungs. Now, in systemic circulation, arteries carry oxygen-rich blood. That means oxygenated blood. And veins carry carbon dioxide-rich blood. Okay? So that's normal, we know that. When we say artery, right? In general, we know what? Arteries carry what type of blood? Oxygenated blood, right? And we say veins carry deoxygenated blood. Is it clear? So that is systemic circulation, remember. Pulmonary circulation is opposite of it. That means what? Arteries carry deoxygenated and veins carry oxygenated. Is it clear? So pulmonary is opposite, just opposite. So that is another difference between systemic and pulmonary. Number 3. Systemic circulation is a greater circulation or greater circuit, because your heart is here and it is between the heart and whole body, right? So it's a long circuit between the heart and the whole body. So vast. Pulmonary is between heart and what? 2 lungs, right? So your lungs are very close to the heart, right? Just next to the heart, both sides. So it's a short circuit circulation or short distance circulation. Okay? Makes sense, right? Heart and lungs, they are very close to each other. So only this area, you see? Only this area. Systemic is throughout the body. Systemic circulation is high pressure circulation. Pulmonary circulation is what? Low pressure. tell me, if your heart wants to send blood to your lungs. Lungs are just next to the heart, right? So it doesn't need heavy pressure. But to send to the head or leg throughout the body, it must pump very forcefully. Make sense? So the pressure in systemic circulation must be much higher than pulmonary, because pulmonary is only sending from the heart to the lungs. Here, okay? So systemic circulation, the pressure is high. Pulmonary circulation, the pressure is low. So when your heart pumps the blood to the body, must contract much forcefully, left ventricle. Okay? Right ventricle sends the blood to the lungs. So the contraction is much weaker than left ventricle. Make sense? Left ventricle sends to the body, and right ventricle sends to the lungs. So which one has to pump more forcefully? The left one. Make sense? So goes to the body, sent to the body. Okay, so that are the circulations. Is it clear, everybody? Okay. So you see here, heart and two lungs. So this is pulmonary circulation and heart and the whole body system. Now I'll quickly explain the systemic and pulmonary circulation so you will remember. Okay? First, two things, if you remember, will make everything easy. One is, just remember two things that will explain the systemic and pulmonary much better. One is, left side of your heart carries oxygen-rich blood, and right side contains or carries carbon dioxide-rich blood. So that is one thing you need to remember. Left side, oxygen-rich, oxygenated. Right side, carbon dioxide-rich. That means deoxygenated. Is it clear? That is one thing. Number two, atria. You have two atrium. Atria is plural. Receive blood from outside and ventricles, you have two ventricles, send blood to outside. Okay, those two things. Let's go back. Left side of your heart contains what type of blood? Oxygen-rich blood, oxygenated blood. Right side contains deoxygenated blood. Is it clear? Okay. And atria receive the blood from outside. You have two atrium, two chambers, two atria, and ventricles pump the blood to the outside of the body. Okay. Now you tell me, heart sends the blood to the lung in pulmonary circulation, right? Heart sends the blood to the lung. What type of blood should go to the lung? Why blood goes to the lung? To get the oxygen. We all know that, right? Blood goes from the heart to the lung to get the oxygen. So deoxygenated blood goes to the lung, right? And gets oxygen and becomes oxygenated. Make sense? And oxygenated blood comes back into the heart. Make sense? So that is the pulmonary circulation. Is it clear? Okay. Then, now heart has the oxygenated blood, right? That oxygenated blood should go to the lung or to the body? Your body needs oxygen, right? Continuous oxygen supply. We know that. Tissue. So, heart now will pump the blood to the whole body. that oxygenated blood, right? And tissue will receive the oxygen. Tissue needs oxygen, right? And give carbon dioxide to the blood. That is the exchange. Okay? Tissue receives oxygen and gives carbon dioxide to the blood. Blood will bring that carbon dioxide into your heart. Okay? So that is the systemic circulation. Now, in systemic circulation, heart sends oxygenated blood to the body, right? And brings carbon dioxide rich blood into the heart back. That is systemic, right? Okay. So, if I ask you, which ventricle, we know that ventricle sends the blood to the outside, right? Which ventricle should send blood to the lungs? Just think, what kind of blood goes to the lung? Deoxygenated, right? And which ventricle contains deoxygenated, right or left? Right. Very good. We know that right side contains deoxygenated, right? So right ventricle will pump the blood to the lung. Okay? Is it clear? And then blood will get the oxygen, and blood returns into which chamber? Atrium. Right? Atrium receives the blood from outside. So which atrium? Now this is the tricky question. Oxygenated blood, right, coming back from the lung. Which atrium will receive that, left or right? Left. Make sense? Because we know only left side contains oxygenated blood, not in the right side. Make sense? So that is the pulmonary circulation. Now let's go to systemic circulation. In systemic circulation, heart sends blood, oxygenated blood to the body, right? So which ventricle has oxygenated blood? Left. So left ventricle will forcefully, very forcefully contract, right, to send the blood throughout the body. So left ventricle contains oxygenated blood. It will pump the blood to the body. Make sense? Now, blood gives oxygen to the tissue, gets carbon dioxide, and becomes deoxygenated, right? Carbon dioxide rich. Now you tell me that deoxygenated blood from the whole body should return to which atrium, right or left? Right. Make sense? Because right side deoxygenated. Is it clear? So just remember those couple of things and think why blood goes to the lung, why blood goes to the body. Blood goes to the lung to give the oxygen, right? And blood goes to the body to give, blood goes to the lung to get the oxygen, and blood goes to the body to give the oxygen. Make sense? That's the difference. Okay. Structure of the heart. Heart is protected and covered by a double layered connective tissue structure that is called the pericardium. So your heart is protected and covered by a double layered connective tissue structure. One layer is attached to the wall of the heart like this, and then it folds here like this and covers the heart like this. So this is a double layered connective tissue structure that is called the pericardium. Peri means what? Around. Okay? It's a perimeter. Measure the perimeter, right? That means around. So around the heart you have, cardia means heart, so around the heart you have the pericardium. How many layers it has? Two. Inner layer is attached to the heart, and that is called the visceral layer or visceral pericardium, same thing. The outer one is called the parietal layer or parietal pericardium. Inner visceral, outer parietal. And in between you have small amount of fluid, and that is called pericardial fluid. Makes sense, right? Pericardial fluid. Small amount of fluid. This fluid is like lubricant. You know lubricant? It's like slippery. When your heart contracts, right, and relaxes, these two layers move like this in opposite direction, and that fluid prevents the friction between the layers. Make sense? That lubricant fluid prevents the what? Friction. Now, there is a clinical condition that is called pericarditis. Pericarditis. Itis is inflammation, right? Any itis, meningitis, tonsillitis, pharyngitis, conjunctivitis, hepatitis, nephritis, right? You can add like many. So, pericarditis, very simple inflammation of the pericardium, right? Covering of the heart. Now, in pericarditis, when inflammation occurs, we know that swelling occurs, right? So, these membranes get thick and red swell. So, the chance of friction increases when they get thick, right? Come close to each other, and when heart contracts, right? Or when you do coughing or sneezing, okay? This friction occurs, okay? And that causes sharp chest pain. Sharp chest pain, okay? In pericarditis. Usually viral infection, but could be also bacterial or fungal infection. Okay. So that is the covering of the heart to protect your heart. Now, another clinical condition in which excess fluid accumulates in this space. Usually small amount of fluid, I mentioned, right? Small amount of fluid is there, normal, lubricant fluid. But sometimes a lot of fluid can accumulate, and that becomes a problem, because just think that around the heart, if you have a lot of fluid, then heart will not be able to expand. Make sense? Because of pressure of fluid. Pressure has increased around the heart, right? So heart will not be able to expand, right? So will not be able to forcefully pump the blood out. Make sense? So that will decrease the blood pressure. Okay? And that is called tamponade. Tamponade is the increased pressure around the heart, inside the pericardium. Inside the pericardium, pressure goes up due to excessive accumulation of fluid that prevents the heart to expand and forcefully contract. Okay. Chambers. How many chambers human heart has? Four. 2 atria, 2 ventricles. So you have 4 chambers, okay? Upper 2 chambers are atria. This is right atrium. Atrium is singular, atria is plural. So atrium, we have right and left. So left atrium. Then we have 2 ventricles. Left ventricle, right ventricle. So upper 2 chambers are atria, right? And lower 2 chambers are ventricles. I have already mentioned the function. Atria receive the blood from outside, right? Atria receive the blood from outside. And ventricles do what? Sends the blood to the outside. Okay? So which one should contract more forcefully? Ventricle, right? Because to send the blood to the outside needs more pressure. You see what happens. Atria receive the blood from outside, so blood gets into the atria. Then atria do what? Contract weakly, not very forcefully, just to send the blood to the ventricle. So atria receive the blood from outside, right? To receive, you don't need the contraction. It is receiving and sending where? To the same side's ventricle. The ventricle is just below the atrium, right? So it doesn't need to forcefully contract to send to the ventricle because its ventricle is just under it. So very weak contraction of atrial wall will send the blood to the ventricle. Make sense? Right atrium will send to the right ventricle, left atrium will send to the left ventricle. Okay? By weak contraction. Now ventricle sends the blood, right ventricle, deoxygenated blood to the lungs, right? So it contracts, and left side ventricle contracts most forcefully because blood goes to the body. Is it clear? So this side, this chamber, left ventricle contracts the most forcefully. Most forcefully because it sends to the systemic circulation to the body. This one sends to the lung, so it needs to contract but less forcefully than the left ventricle. Okay, now you tell me, if I ask you that which wall should be stronger to contract forcefully, atrial or ventricular? Makes sense, because atria just send the blood down to the ventricle, right? Gravitational force will send the blood easily, right? Weak contraction will open the valve, blood will rush. Now if I ask you, so ventricular wall is much thicker than atrial wall. Now if I ask you, which ventricular wall should be thicker, left or right? Left, because left sends to the whole body, right? Right sends to the lungs. Make sense? So left ventricular wall is the thickest and strongest. Is it clear? Okay. Valves. In your heart, there are 4 sets of valves. 2 semilunar and 2 atrioventricular valves. Okay, so these are 4 sets of valves. Okay. How many? 4. 2 are called the semilunar valves and 2 are called the atrioventricular valves. So which ones should be in between atrium and ventricle? AV, atrioventricular. Its name is telling you, right? Atrioventricular or AV valves. So we have AV valves here between the atrium and ventricle. Atrium, ventricle. This is left AV valve. This is right AV valve. Make sense? So you tell me, AV valves should open upwards or downwards? Because we know blood goes from atrium to the ventricle, right? When ventricle contracts, blood should go outside. If, when you see here, this is atrium, this is ventricle. Atrium contracts to send the blood to the ventricle, right? Now when ventricle contracts, if the blood goes back to again atrium, doesn't make sense, right? So when ventricle contracts, AV valves get closed. It will not let the blood go back to the atrium. Make sense? So that's why it's open in one direction, only downwards. Unidirectional, right? Not bidirectional, only downwards. When ventricle contracts, we'll go back and stop. So that is important to know. AV valves open downwards. Now, semilunar valves are located at the root of the pulmonary trunk and aorta. So Those two are the semilunar valves. So one is called aortic semilunar valve, another is pulmonary. So semilunar valves are two, aortic semilunar and pulmonary semilunar. Aortic, you see here, this is the aorta. So at the root of the aorta, and this is the pulmonary tract. So here, if you look here, pulmonary semilunar valve, see here, when you will see in the lab, you will see it more clearly. And at the root of the aorta, you have aortic semilunar valve. Okay. So those are the valves. There is a clinical condition that is called valvular stenosis. Valvular stenosis is a clinical condition in which the valves get narrow, so the opening inside the valve gets narrow and valves get harder, stiff. Okay, so that is the valvular stenosis, narrowing and hardening of the valves. Okay, so it will allow, it will not allow a lot of blood pass through it because it got narrow, the opening got narrow, and the valves will not open fully because they stiff, got stiff. So will not open fully and the opening is narrow. So less blood will go from one chamber to another. Make sense? And it will take longer time. If the space gets narrow and valves don't open fully, then what will happen? Your heart chamber is trying to push the blood, right? But space is less there. Opening is narrow. So that will cause sometime a sound. Okay? That sound, abnormal sound, is termed as murmur or murmur. That prolonged sound of friction of blood. Okay? You can listen this sound using a stethoscope, that abnormal sound. Okay, so that's the valve of the heart. Blood vessels. This is important to know that two types of blood vessels are attached to the heart. These are large blood vessels, see, attached to the heart. These blood vessels are to do what? Take the blood out from the heart or bring the blood into the heart, right? So these are large blood vessels. In the wall of the heart, you have blood vessels too. These blood vessels are to do what? To supply oxygen and nutrition to the wall of the heart. Make sense? So function is different, right? These large blood vessels are doing what? Taking the blood to the outside and bringing the blood into the heart, right? And these small blood vessels, those are in the wall of the heart to provide oxygen and nutrition to the heart tissue, wall of the heart. Is it clear? Okay. So these blood vessels are supplying blood to the wall of the heart. These are called the coronary arteries. Have you heard that? Coronary arteries supply blood to the wall of the heart. Make sense? Okay. Inside the heart, you have a conductive system, special tissue structure. That is the conductive system, highly specialized tissue structure. That tissue structure can do two things. One is generation of electrical impulse and transmission. So production and transmission of what kind of impulse? Electrical impulse. That's the function of the conductive system. I mentioned just a couple of things. Highly specialized tissue structure inside the heart. That is the conductive system. What is the function? Production and transmission. What kind of signal? Electrical signal. Do you know that your heart generates electricity, electrical impulse that spreads throughout the body, and you put the leads, electrodes, to pick up that electrical signal. That is called what? EKG. Basically, EKG is the electrical signal that is produced in that conductive system, spreads throughout the heart. Not only that, electricity, electrical signal, it will also spread throughout the body, but generates inside the conductive system of the heart. That we want to pick in EKG and do the analysis. Is it clear? So EKG is the electrocardiogram. So conductive system is present inside the heart. We have already talked about the covering, we have talked about the chambers, 4 chambers. Now, we'll see the external of the heart, outside features of the heart. You can identify the atria and ventricle from outside, because we know atria are located in the upper part, right, and ventricles are located in the lower part, and there is a sulcus groove in between atria and ventricles. There is what? Groove. That is called sulcus. So I can easily separate, you see here, atria, ventricles. There is a groove or sulcus. That is called the coronary sulcus. Coronary sulcus. And another way to identify the atria and ventricle and right and left ventricle is, if you see the pointed lower end, which is called the apex of the heart. See the pointed lower end? It's cone shape, right? So pointed lower end, which is directed down and to the left. So this is the left part of the heart. Okay, so we know this is left ventricle because we know that lower part is the ventricle, right? Lower chambers are ventricles, and this is the left side, pointed apex. Another way is, we know left ventricular wall is thicker than the right ventricular wall, right? So when you do the dissection of the heart, have you done it today? You did the dissection. So if you press the wall, you can tell which one is thick, which one is thin, okay? So of course, if you cut, you can see thick and thin, but from outside, we can also tell. This is left ventricle, this is right ventricle, okay? These are atria, these are ventricles, by looking at the sulcus. Okay. Now, in the heart, you have coronary sulcus or groove that separates atria above, ventricles below. Also, you have interventricular sulcus in between the ventricles. In the front, you have anterior interventricular sulcus. In the back, you have posterior interventricular sulcus. So, let me write it down. It will be easy for you. What are the sulcuses in the heart? Coronary sulcus between atria and what? And ventricles. Okay, so like this. Above is atrial, below is ventricle, and interventricular, in between the ventricles. Interventricular sulci. There are two, anterior and posterior. Now, inside the sulcus, in that groove, you have fats and blood vessels, arteries and veins are located inside the sulcus. So now let's see here. This is coronary sulcus, separates atrial and ventricle. You see fat and blood vessels, arteries, veins. This is anterior view, front. So anterior interventricular, in between the right and left ventricles. This is anterior interventricular sulcus, also contains the blood vessels, fats. Same thing in posterior. If you go to the back of the heart, you have posterior interventricular sulcus. Okay. So those are the external